Okay. All right, look at these two triangles. They're not congruent. Let me fix that a little bit. Okay, they're not congruent, are they? These two triangles are not congruent. And we've already discussed it's a dilation because we made that triangle got smaller. It's a dilation. So the sides didn't stay the same, but the sides stayed proportional. But what happened to the angles? What happened to this 90-degree angle to it? It stayed the same. It was 90. It's still 90. Okay? So what do you think happened to this angle? This angle corresponds to the angle. You think it's the same?
Yes.
It is. So if this is 40 degrees, then this is going to be 40. Because, listen, the angles give the triangle or the figure its shape. The shape didn't change. The shape didn't change. So the the angles didn't change. Because the shape stayed the same. Okay? So if that's 40, that's 40. So what do you know that has to be? Why? 90 plus 90 is 180. And there 3 angles in a triangle have to equal 180. So what do I automatically know E is? Why does it have to be 50? How do we know automatically? It's the same. It stays the same, but we know that if 40 and 50 make 90, 40 and 50 make 90 over here. Correct?
Yes, ma'am.
So triangle ABC is similar. And that's the sign we use when when numbers are almost. Well, in geometry, it means they're similar. That means they're almost the same, but the sides are not the same. The angles are, but the sides aren't. So the sides stayed proportional. Remember? Oh, well, let's talk about this no, let's go ahead and do this. So the sides stayed proportional. Wait, let me write it up here. So if that's 12 and that's 8, this is 9, and I'm trying to find the length of that side right there. How would I write this as a proportion? Go back. 12 over. Let's do 8. We could do 9, but it confuses some people. I write it like I see it. 12 over 8. 12 is the height. 8 is the base. 12 over 8 equals. And if you write it that way, guys, if they need the scale factor, you can find the scale factor. Okay? Because you're going from one triangle to another. So let's leave it just like that. Now, there's something I could do. I could reduce that before I start solving for x. But right now, I don't want to. We're going to in a minute, but right now, I don't want to reduce it. So if I'm trying to find x here, when two fractions are equal, what do we know? The cross products are equal. So I call it the crisscross. You're going to crisscross. So what do I write? 12x. I'm going to put x on the left. I'm going to put my variable on the left. So 12x has to equal, which is 72. Does everybody see why I wrote 12x equals 72? Okay, so 12 times x equals 72. Now I'm going to divide by 12. So x equals 6. So I know that x is 6. Okay, does everybody see how I got the 12 over 8 equals 9 over x?
Yes.
9 is the height on the smaller triangle. X is the base. It has to correspond right there. Okay, you're getting that? All right, on page 208. Look at the very top. We're going to talk about those two things today that I just went over on those triangles. If two angles, it's called the angle-angle similarity postulate. Okay? Angle-angle, two A's. If two angles of one triangle are congruent to two angles of another, then the triangles are similar. Now, if the two triangles are congruent, they're going to tell you that. I mean, they're exactly the same. Everything's the same. But if they're not exactly the same, and you're trying to find out if they're similar, then you look. Only two angles of one has to be congruent to two angles of the other. Because we just learned that if two angles are congruent, then this third one obviously has to be the same. There's nothing else it could be. That's all they're saying. So let's look right here. Circle the hundreds. 100 and 100. So that's one angle that's congruent on both of them. And they really drew these triangles too close to the same size for my liking, but they're not congruent. These triangles are not congruent. So 100, 100. This is 45. So let's find A. What's the measure of angle A? 35. Good job. So, hey, look at there. 35, 35. So what do we know about these two triangles? No, they're not congruent. They're similar. But yeah, because they're telling us, hey, if you got two of them the same, there's no sense in doing the other one because you know it's the same. If there's nothing it could be. There's nothing else that B could be right now. The measure. So, but you only have to test two. Well, you have to make sure two of them are congruent. Okay. Does everybody understand that? That's called the angle-angle similarity postulate. Okay. So look at the bottom. Number 3. Circle the 70s. So we know one of them's corresponding is congruent. Go find the measure of that one. That angle right there. Good. Trent already has it. Good. Brooke has it. Tori has it. Caitlin has it. Madison has it. Daniel has it. Oh, Megan. Kristen. Boy, y'all are getting it fast. Yeah. Okay. Tori. What'd you get, Sean? Okay, let's look. It's 52 because 52 plus 58 plus 70 is 180. Good. Uh-oh, we got a problem, don't we? We got a problem, don't we? He meant, yes, we do. It's what? No. They are not similar. Right. There is only one congruent angle. No, they are not similar. There's only one congruent angle. The 70s. There has to be two. At least two. If there's at least two, then you know there's three. So that means they're similar. Okay, turn the page. Let's work on the proportional part of it. Okay, who plays tennis? Anybody in here? Okay. Look at Matt. He is playing tennis. He is 12 meters from the net. Here's the net right there. So he's 12 meters from the net. And the net is 0.9 meters high. He needs to hit the ball so that it clears the net and lands 6 meters beyond the net. Beyond means past. So here's A right there. There's where the ball hits. At what height should Matt hit the tennis ball? Everybody go circle the H. That's what we're trying to find out. Always circle what you're trying to find out. Okay, now let's use a proportion, and we're not going to use theirs. We're going to use our own. So we're going to come over here in the margin, set a proportion up. Okay, let's all do the same one, so we'll be on the same page as we solve it. So what are you thinking y'all want to put? Oh, hey, does everybody see the small triangle that's inside that larger one?
Yes.
Okay, so we've got a small one, a large one. Do the small one first. What do y'all want to put? What dimensions do you want to put for the small one?
6 meters. 6 over 0.9.
Okay, and you know what? I'm going to put 0.9 over 6 just because that's the way I see it right there. 0.9 on top of 6. So wait a minute. 0.9 is the height. 6 is the base. Good. Now look at the large one. What's the height of the large one?
6 over 12.
Well, let's use H, okay? Since I used H, let's use H. Over.
12.
Nope. 18. Why is it 18? 6 plus 12 is 18. Look at there. 6 plus 12 is 18. Does everybody see that? Now, we can't. There's something obvious that I see right now. We got to just do it that way. Who sees it? We don't need to do the crisscross. There's something easy we can do right now. Oh, Aaliyah, what do you think? Good girl. So we're going to go 6 times 3. Y'all see it? 6 times 3 is 18. If it's easy like that, don't do the crisscross. I mean, you can do the crisscross. You're going to get it right. But remember, I like for you to make it easy. So what's 0.9 times 3?
2
Good. 2 7/10. Now let's read. At what height should Matt hit the ball? Everything is in meters, so this answer is in meters. So 2.7 meters. He needs to be able to jump. His vertical needs to be 2.7 meters. Or, well, no, he needs to be a total of 2.7 meters. His vertical can't be that. Because 2.7 meters is almost, well, not quite. Because this is 3 meters high, this signal. So he needs to get up pretty high to get it 6 meters past there. Okay, turn the page. Now, Rosie is building a wheelchair ramp. Guys, do you see who might use the proportional stuff? People that build bridges. People that build stairs, ramps.
Elevator.
Do you know that when you have, there's building codes on like the stairs, how steep the stairs can be and all? There's building codes now. There used to not be. But there's building codes, and to get it to pass inspection, they have to be a certain slope, okay? Steepness. So this is one, if you're building a wheelchair ramp, you need to know about you know, doing proportional sides and all that. So let's come over here in the margin. Do you see the smaller triangle and the larger one? Okay, let's circle the H. So let's do the smaller one first. What do y'all want to put the smaller one? H over 8. So 8's the base. 2 over 24. You good with that, everybody? Okay. Oh, I see something easy. Yeah, 8 times 3. But, then I have to go, what times 3 is? 2. And that's tricky for some people. I want to practice crisscross anyway, so let's just crisscross it. And we could reduce that, but some people are not very good at reducing. We're going to do a reducing one in a minute, but so let's crisscross. 24 H equals 16. Good job. Does everybody see y divided by 24?
Yes, ma'am.
What'd you get? 16 divided by 24, I know it's going to be point something. Yes. So, what is point, repeating 16 by 24? 2/3. Look, guys, since 16 is smaller than 24, I could just reduce by 8, huh? And get 2/3. Okay, what is 2, 8, and 24? What are all their dimensions? 2 what? What unit? 2 what? Feet. So we're going to put 2/3 feet in the blank. And then I'm going to go read the question. What is the length of the support piece in inches? Don't say it out loud. I want everybody to have a chance to try to figure it out. 2/3 feet, how many inches would that be? Good. 2 people have it. I hope. 2/3 of a foot is how many inches? Okay, you put your hands down. I see ya. How many inches are in a foot? Good. So 2/3 of it. 2/3 of it. Who thinks they know? Say it.
9 inches.
I heard 9 and I heard 8. So let's, okay, what is a third of 12? What's a third? 4, right? So 2 of the 3 is going to be 8 inches. Okay, look at number 6. The lower cable meets the tree at a height of 6 feet. So right here, the cable, this lower cable, put a 6 right there. That's the height of that cable going up. And it extends out 16 feet from the base. Remember, the base is at the bottom. Base is the bottom. I want to know how high the tree, how tall the tree is. So I'm going to come over here and do this. Circle the X. That's what we're trying to find out. Guys, y'all have seen pictures of the redwood forest. Has anybody been to California and been in the redwoods? Okay. Well, I've been to California. I haven't been either. Look. But they still have like the tallest tree, how high it is. Do you think that somebody gets in this big, huge bucket truck and measures with a measuring tape all the way down?
They use the shadow.
They use the shadow. And they do a proportion. They set a proportion up. So they have like a stick, and they know how high the stick is, and the shadow on the ground, and then they do the shadow of the tree, and they find the height of the tree. Right? So, look, and that makes it so much easier. So let's go set a proportion up. What am I going to write? 6/16 will work. And, you know what I forgot to say? There's other ways. Well, I said it once, but there's other ways we could be setting this up. I could put 16/6. You know, or I could use the 56 and the X first. Okay, but I'm just going by what the first person tells me. 6/16, the height over the base equals what? Yeah, and well, let's put H. That's better because we're doing the height. H over 56. This time they didn't trick us, did they? They added it for us. Okay, we got to reduce here. It's just too easy. It's just too easy. What's half of 6?
3.
What's half of 16?
8.
Oh, 8 times what gives me 56? 7. So 3 times 7 is, okay, now let's think. 6 feet, 16 feet, 56 feet. All this is feet, so what's 21? Feet. How tall is the tree? 21 feet. Okay? Okay, shh. Turn the page. Look at 211. Oh, not 211, excuse me. Look at 212. So let's kind of review what we've learned. Give me the measure of angle B. Angle B.
109.
109. Oh, circle 109, 109. What else can we circle? 30 and 30. So what do we know? And so, good. The triangle ABC has angle measures of 109, 41, and 30 degrees. And angle DEF has angle measures of 109, 41, and 30 degrees. Because, and really, there's three angles, right? But all we need to worry about are two of them. So because two of the angles, look, put two angles, you can abbreviate, in one triangle are congruent to two angles in another, we didn't even need to talk about the 41. See, I mean, Kristen knew automatically, and several of you knew that it was 41. But, I mean, we wrote it in there because it's so obvious. But we just need to worry about two of them. Okay, the triangles are similar. They're not congruent, are they? Nope. Okay, number 2. A flagpole. Here we were talking about shadows a while ago. The flagpole casts a 23.5 feet long shadow. At the same time of day, it's got to be the same time of day, exactly the same. At the same time, she is 5.5 feet tall, casts a 7.5 feet shadow. So, 5.0, we're trying to find H. What am I going to put? 5.5 over, good, equals H over, nope, they tricked you. They got to add, and see, they told us right up here. You got to add those, because that's the, hey, you might want to do this. So, let's come over here, and we're going to crisscross. Crisscross. What do I write first? No. 7.5H equals, no, 129.25. Where did they get that? Times 5.5. You've got a crisscross. When two fractions are equal, their cross products are equal. So now I've got to divide by 7.5. What do you get?
I got 17.1.
Oh, 17. I thought y'all said 12. 17.2 repeating 3. So it says round to the nearest tenth. So what would that be? Is that right? Yes, because 2 is in the tenths, and 3 tells you to leave it alone. Good. Okay, look at number 3. Two transversals intersect two parallel lines as shown. So here's your two parallel lines. There's two transversals. Explain whether ABC and DEC are similar. So, triangles. Oh, you mean down a little bit. Okay, there you go. Okay, so BAC, everybody look. Angle BAC, this one right here. And EDC, that angle, here's the transversal. Are they congruent?
Yes.
Yes. They're alternate. Interior. They're inside. They're alternate interior. This is inside the parallel lines, guys. There's your transversal. So, yes, these two are congruent. Oh, okay, we'll finish on Monday. Y'all have a good weekend.